This is another DocWatt quick video. There's nothing fancy here. We're just going to try and give a quick answer to a question that somebody's asked. In a previous video, we compared permutations to presidencies. Here we're going to compare combinations to counting how many committees you can choose from a group. So suppose that we had a group of 5. We'll A, B, C, D, and E, we'll give them those names. And we wanted to choose a committee of 3 out of that group. Let me tell you a little bit about some notation that's used for combinations. This kind of parallels some of the notation that we use for permutation. But combination out of n, in this case would be out of 5. We want to choose R. We're talking about choosing 3 out of this set. That's a notation for saying find all the committees of size R from a set N. Those are all the combinations. Another notation that's used, paralleling the notation that we used with permutations, is N choose R. That's often the way that it's pronounced. And finally, a third notation that is still used, it's an older notation, but N R in parentheses. It looks like a fraction without a fraction bar in there, but N choose R. Okay, so in our case, we're interested in out of 5 things, we want to choose a committee of 3. Okay, I would suggest that you stop the video here for a few minutes and list all the committees of 3 that you can make out of those 5. So pause for a moment. Okay, you may have found that there were in fact 10 committees that could be chosen. Let's look at them real quickly. You could have made a committee with A, B, and C. Now notice the order doesn't matter here. So the committee ABC is the same as the committee BCA or CBA or BAC and so on. You'll notice that out of those 3, when we were building presidencies or permutations, there were actually 6 different presidencies that we could make out of those 3 people. But when we're making committees, that's one committee. Those same 3 people would make 6 permutations. We might look at what other ones there are, A, B, and D, A, B, and E, and I think that's all of them with A and B in them. There could be some others with A, C, we already have one with AC, so this can't be a B, but it could, and it can't be a C, and it can't be an A, so it could be a D, an A, C, and E. And finally, we've got some that have A and D in them, A, D, and E. And those are all of them that have an A in them. You can verify that for yourself. We could worry about finding all those that have a B in them. We've already got a bunch of them that have B's in them. Notice there's 3 of them here already. So BAC, we don't want that one. BAD, we don't want that one. And BAE, we don't want that one. But there is a BCD that we need, and a BCE, and finally a BDE. Now notice, there were 1, 2, 3, 4, 5, 6 of them that had an A in it. There's also 6 of them that have a B in it. 1, 2, 3, 4, 5, 6. Okay, let's worry about all those that have a C in it. We've got some that have C in it already, in fact quite a few. Notice there's 1, 2, 3, 4, 5. There's 5 of them that already have a C in it. C, D, and E. There's the 6th one that has a C in it. Let's count them all together. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 10 of them that are there. So what we have shown is that out of 5, we're going to choose committees of 3. 5, choose 3. That would be another way of writing that. 5, choose 3 is going to be equal to 10. Now let's look at some more general ways of counting that. In general, if we were looking at finding out of n things, we want to choose r of them, then here could be a way to count them. We could count all the presidencies or all the permutations that you could find, and that would count too many. Remember over here when we were counting this committee, that committee shows up as a presidency 6 times, and every one of these other committees show up as presidencies 6 times. In this case, in the more general case, we want to divide by all the ways that one committee shows up as presidencies, so that we're just counting the committees instead of the presidencies. Okay, that's the big, that is one way of defining this formula. Let's look at it for a minute and clean that formula up just a little bit. Let's say that out of and choose R, we're going to look at, we know what that formula is from our previous video. It's n factorial divided by n minus r factorial. And then this part is r factorial divided by r minus r factorial. Remember though that r minus r is 0, and remember 0 factorial is just 1. So this part on the bottom is just r factorial divided by 1, or in other words, r factorial. So a little bit of algebra cleanup here. This becomes n factorial over n minus r factorial. There's the permutation, and then we're going to divide that by r factorial so that we take out the repeats that were being done there. Okay, that formula is the more usual one that you'll find when you're looking it up somewhere. Let's just check and see how that works in our particular case. Remember, we were looking at out of 5, we're going to choose 3. So this formula says that would be 5 factorial, the n factorial, divided by 5 minus 3 factorial, that's a 2 factorial, times a 3 factorial. So you can see where everything's coming from in that formula. Calculating that real quickly, that's a 5 times a 4 times a 3 times a 2 times a 1. That's the definition of 5 factorial. 2 factorial is a 2 times a 1, and a 3 factorial is a 3 times a 2 times a 1. So those 2's cancel, those 3's cancel, this 2 will cancel one of those and make it a 2. We've got a 5 times 2 times 1 on top, that's a 10, and a 1 on the bottom, that is 10. It's counting up those 10 committees that we could choose from there. Okay, that's the end of the video.